everyone. I'm Shruti Singhal from Think Question Private Limited. Today in this session, we are going to cover a very important topic, that is non-functional testing. In the previous session, we have discussed about the different type of functional testing, the levels of testing, and then we have also discussed about manual and automation testing. So let us discuss the agenda of this session. In this session, we are going to understand what is non-functional testing and what are the parameters we test in it. What is the advantages and disadvantages of this testing? Then we are going to dive into performance testing and its type. We are also going to understand the difference between functional and non-functional testing. Then we are going to cover a very important life cycle, that is a bug life cycle or a defect life cycle. Moving ahead, we will understand the severity and the priority of a bug. Then we have already discussed about regression testing. So we are going to understand what is the difference between regression testing and retesting. And then we are going to take test cases of any real life entity. So guys, let's get started. So very first thing is we are going to discuss is what is non-functional testing. So as described over here, it is a type of testing wherein we emphasize on the performance of a system. We actually check the performance of a system on certain conditions. We are not checking any kind of behavior or functionality over here. That is actually called as functional testing. So how does we verify? We verify the performance, we verify the usability, reliability, the load, and a lot of other attributes in this particular application. So that is how functional testing and non-functional testing is going to differ. So what are the parameters that we actually cover? We are going to discuss next in this particular session. So now let us discuss why it is important and why we are doing it. So here we basically check how well my system is going to perform in certain conditions. We are also going to check, is my application secure or not? Can it handle any kind of load or stress? And we also check the compatibility of the system in various environments. We also check whether the system is easy to use and whether it is accessible to the client or not. So there are a lot of types of various types of functional testing available, like performance testing, load testing, stress testing, scalability testing, usability testing, and so on. So we will discuss them later. So let us have a quick idea about very important type of non-functional testing, like performance testing. So when I talk about, let's say if I have to check the performance of a particular application. So suppose we have a login API. So we need to check the response time of this login API with 1,000 users login in simultaneously. So that is called as performance test. Whereas if I talk about load testing, basically in this, I'm going to check what if thousands users suddenly log into my system. So that is load testing. Whereas what is security testing? So let's say if I have a password. So is my password going in an encrypted format or not? Is it easy to be guessed or not? That is security testing. Similarly, we might have usability testing. So we need to ensure over here whether the users can complete a purchase within certain amount of steps on an e-commerce website. Or are there too many steps to purchase a product? So that is the usability testing. And the compatibility testing might be like, for example, the application is working similar in every browser, whether it is Chrome, Edge, or Firefox, or whether it is on iPhone or it is Android application, Android phone, it is working the similar in every phone, right? So that is compatibility testing. So basically why we are doing it, because it gives us a very good user experience, and it is also going to help us to protect from any kind of threats, the security threats or the breaches that might appear. And we also validate the readiness towards any real world conditions, real type of situations. And also, as I talked about previously also, that there are certain applications like healthcare application or banking application where we need to compliance with the standards for any kind of legal actions. So we also ensure that is happening. So this is all about what is non-functional testing. So now guys, let us understand the parameters on which non-functional testing is performed, which includes security, reliability, survivability, availability, efficiency, integrity, usability, flexibility, scalability, reusability, interportability, and portability. So let us discuss one by one what is the meaning of all these parameters. So first of all, we have the first parameters as security. So what is going to be test and security? So security is nothing but security testing. So we here test that how the system is secure if there is any kind of sudden attack from any kind of internal resource or any kind of external resource. So how it is going to behave. Then we have reliability testing. So here we actually check that to what extent the system is going to perform if there is any intended functions without failing, right? So it basically defines the extent to the system performance, its intended functions without any kind of failing. So that is reliability. Then is survivability. So survivability is basically recovery testing. How my application is going to survive in various conditions. So we check basically the software system is able to recover itself in any kind of failure, and it is continuously performing with some functions without any kind of failure. So that is called as survivability. Then we talk about availability. This is a part of stability testing. So availability means the percentage of available software systems to the original servers. That means the degree to which a user can rely on this particular software during any kind of operation, right? For example, if I'm doing payment, so how much I can rely on this particular website, that is the availability. Then the next parameter is, guys, efficiency. Again, all these parameters mean some or the other a similar thing. They just have a very little difference between them. So efficiency is extent to which the software system can handle any kind of quantity or the response time, right? Then we have integrity. So how my source code quality is when it is passed to the QA is integrity. So here we check the quality of my source code. Then we have usability. So this is nothing but usability testing. So how easily the usable system is from user's perspective. So from user perspective, am I able to navigate easily? So that is a usability testing, and this is also a part of functional testing. Then we have flexibility. So this means what? That how well the system can respond to any kind of uncertain condition, right? So how well it can perform. That is the flexibility of the system. The next parameter that we have is scalability. So here we are going to check the degree to which application can scale up, right? Or scale out for its processing capacity. So if there is an increasing demand of that particular application, how much it can scale, right? So that is called as scalability. So these are the parameters for non-functional testing. So these are the parameters that we verify whenever we are performing non-functional testing. Now guys, let us proceed to the advantages and disadvantages of non-functional testing. So first of all, let us discuss the benefits of non-functional testing. So first thing is that non-functional testing enhances software quality and user satisfaction. So the very first point is improved performance. So since we are checking the performance of the system before actually deploying or releasing it, so it determines any kind of bottleneck, right? Any kind of bottleneck that might appear and that might hamper the performance of the system. Moreover, it is less time consuming. So it is overall less time consuming if I talk about any other type of testing process. And it improves my user experience because we have some testing like usability testing where we are checking how easily usable it is and how user friendly the software is for the user. So we actually focus on the overall user experience on the application. And since it has security testing also, so if there is any security bottleneck in an application, we can also check it, right? So that is the benefits of non-functional testing. Now guys, let us discuss about the limitations, right? So limitations, so whenever there is a change in the application, then we have to perform the non-functional testing again, right? So that is very much resource intensive. Like functional testing, many of the non-functional testing cannot be automated. And it is expensive in case of software update. So if there is any update, the non-functional testing is done again and again, and thus it is going to we are going to incur some extra charges to re-examine that software again, and then the software then becomes really expensive, right? So that is the disadvantages of, or we can say limitations of, non-functional testing. Now guys, let us proceed further. Now we are going to discuss about performance testing in depth. So what is performance testing? What are the parameters that we measure in performance testing? Let us discuss about that in deep. So let us first of all talk about what is performance testing. So performance testing is, guys, where we actually evaluate the performance of the components of a system under a workload. That how my system is going to perform if there is a workload. So we monitor basically the stability of the system under this. So this is a type of non-functional testing, as I have already told you. So we also check here that the performance standards are actually maintained into the implementation, design, or architecture of the system. So what all things do we measure? We measure the speed, the scalability, the stability, and the reliability of the system, right? Or the application. So for doing this, we have a lot of testing tools available. A very common one is JMeter. Other than that, we have OpenSTA, we have Load Runner, we have WebLoad, and many other tools by which you can actually do performance testing. So the tools that is used for functional testing is not same as it is used for performance testing, right? So basically, we are validating the speed, the scalability, or the stability of the system, right? So what are we doing? We are checking the response time, right? The throughput, the resource utilization, right, of a project or a product. So why we are doing it? To mitigate any kind of risk that might appear later when it comes to availability, reliability, or responsiveness of the system. So what is the best time to conduct this type of testing? So the best time to conduct performance testing for any kind of web or mobile application is as early as possible in the software development phase. So it should basically start during the development phase when we are actually creating small components or modules, right? So that is why it helps in identifying if there is any performance issue. Because if we identify those issues later, it will be very much expensive to fix them. And it should be carried out if there is any major release that is going to happen to ensure that the system can handle any kind of unexpected event, right? So what happens when you get some CBSE result or some entrance result of any government examination? You have just seen that that website becomes really heavy, and sometimes the throughput or the response time is very late. You sometimes say the result is coming very late, or the website is taking a lot of time to load. So that is nothing but the response time. So that is why regular performance testing during maintenance is also very important to make sure that if there is any update or change, they are not giving any kind of negative impact on the performance. So what do we measure? As I have told you, load time. So this is the application is how much time it is taking to load and becoming fully functional. The response time and how much time it is giving response to the user request. How much time it is taking to process a request and return a response. Scalability basically means if you increase the load or if you have growing number of users, is it able to handle that? And then we also identify if there is any kind of bottlenecks, right, that is coming, or if there are many users at the same time, that is called as concurrent users that are coming into the to use that particular applications. So this is all about performance testing. Now guys, let us understand the different types of performance testing. So as mentioned over here, other than this also we have a lot like load testing, stress testing, volume testing, capacity testing, soak testing, spike testing. So these are the various type of testing that are available under performance testing. Now guys, let us have a quick review about all these. So what is load testing? So load testing is a testing in which if there is a system or an application, we actually check how many transactions it can handle at a time, right? And we also verify how my system is going to behave if there is a normal load condition and if there is a peak load condition. So that is load testing. Now, what is stress testing then? So in stress testing, we verify the behavior of the system, right? So if the load is going to increase, right, then the design expectation. So it addresses which components are going to fail first, right? So when the stress, when the system is in stress, by applying a lot of load on that, so how much it can handle, right? So it helps us to enable us a design which is more robust. Okay. Then we have spike testing. So now what is spike testing? So here also we determine the behavior of the system under a sudden increase in load. So if there is any large number of users, they suddenly come to our system and there is a huge traffic. For example, there is an e-commerce website and let's say there is a Black Friday sale on the Amazon. Then there is a sudden increase in the users who are going to purchase the website. So that is spike, which is happening suddenly. So that is called as spike testing, how my system is going to behave in that second. Next is guys soak testing. This is also a part of performance testing, which we also called as endurance testing. So here what do we do? It involves running a system under heavy load for an extended period of time. So if there is a heavy load, but it is happening for a long period of time, how my system is going to behave. So this process basically ensures that the software can sustain that load for a longer duration. So that is soak testing. Now, as I told you that endurance and soak testing is same. So we are so you can use any term for this. We are actually checking the long-term stability over here. Next is guys scalability testing. Scalability testing is something wherein we are assessing the application ability to scale up or down when there is a varying workload. So if the user count suddenly increase or the data volume or the transaction load, then how the application is able to handle it. So we base the goal. What is the goal over here? The goal is to identify the maximum capacity of the system, or we can say pinpoint performance degradation points, right? So here we simulate extended workload, increasing demands, and we also ensure that the application can maintain whatever functions it was performing. So it is very critical for our future proof, right? So that is called as scalability testing. Similar to this, we also have volume testing. So these are all similar. Here it is how it will behave when we have large volume of data. So here we basically emphasize more on the database, right? So if we populate a huge volume of data in the database and then we monitor how the systems. For example, if we have huge amount of order history, how it is behaving, how it is it able to fetch that huge amount of order history into your order history tab. Then is capacity testing. Here basically we check, we determine how many users the system can handle successfully. So this is before the performance pull. Okay. So here we avoid any kind of potential problems in the future, right? So we know this is the amount of users that this particular system can handle, right? So you can see all these testing are somehow related with the response time, with the throughput, with the load, with the volume and all these parameters. Now guys, let us discuss further in this topic. So as I told you, there are various type of performance testing, but some of the performance testing are very, very important, which is load and stress testing. So let us deeply discuss about them. So let us start first with the load testing. And let us deeply understand what is load testing, why it is done, how it is done, and all these things. So load testing is, guys, it is a type of performance testing where we are evaluating what? That how my system is going to behave during a normal load and during a peak user load. So here what we are ensuring that my system can handle the expected usage without any kind of degradation. For example, if you have an Amazon website, we know if 1 lakh user is going to be there using the application at the same time, it can handle. My throughput is very fast, my response time is very fast. But as soon as It comes to 2 lakh, doesn't matter, 3 lakh doesn't matter. But when it reaches 10 lakh, at that point there is some degradation that is seen. So that is how my system is going to behave. Is it getting crashed? Is it just getting slowed down? Or just the response time is getting slow? We are just checking that. So here we determine the system performance under expected real world load, and we identify any kind of bottlenecks when my system is going to go live. So we ensure the reliability, the scalability, and the response time is meeting the user expectations. So what is tested in load testing? Basically, again, as I just explained you, the response time, throughput. That means the number of transactions that is happening per second, CPU, memory usage. We also check the database performance, the network latency, right? So let us understand with the help of an example what is load testing. So for example, there is an e-commerce website, as I just said, during sales. And we want to simulate whether 5,000 user browsing and 1,000 user checking out simultaneously is working properly or not. Or for example, there is a banking application and there is some demonetization. So many people are transferring the money from different accounts during the peak hours. So how is it happening? So for example, tomorrow we have a bank holiday for, let's say, we have having an extended weekend coming up, and a lot of people are doing transaction just before that. So that is a peak hour because everybody wants to do the transaction before that. So how it is going to perform in that peak hours? Or let us talk about ticket booking system. So if we are searching, we are selecting the seats, and we are booking the tickets before any kind of popular concert that is going to happen. All right, like this, there is a concert that is going to happen, and we have to select the seats. Then how it is going to behave? That system, how Book My Show is going to behave? Let's say like that. Okay, so there are various tools which are used for load testing, like Apache JMeter. This is an open source tool, right, which is used for web and API load testing. We have a load runner tool, which is an enterprise grade performance testing tool. Then we also have Locust. This is a Python based tool. We also have Gatling. It is a developer friendly tool. Okay, and a lot more other tools are there. And if I talk about CI/CD, that is continuous integration and continuous development, we have cases. Okay. So, for example, let us understand more about load testing by taking some scenario. Okay. For example, I'm searching for a product. So, what is going to happen? I'm going to log in into the e-commerce website. I'm going to search for the product, and then I'm going to check. Right. So, what we have to identify in this? So, we have to have some expected user load of, let's say, 1,000 concurrent users are doing. And then what we do? We prepare a test environment for that. So we basically mirror any kind of production environment as closely as possible. And we run the test using a load testing rule. So we actually generate some virtual user and we simulate that scenario. Okay. And then we monitor and analyze the performance metrics. Here we check the response times, the CPU, the memory, the database stats, etc. And then we identify any kind of bottlenecks. For example, the DB query, the database query is running very slowly, or if there is any insufficient resources. So we fix those issues that are found. And then we retest it to ensure that the bugs that we have found is fixed or not. Right? So we also have some pass and fail criteria. For example, if I have a metric of response time, so if it is taking less than 2 seconds for 95% of the user, it is okay. Otherwise not. For example, if you have error rate, if it is less than 1%, it is okay. For example, CPU usage, if it is less than 80%, it is okay. Right? Memory usage, it should remain stable without any kind of leaks. So we define the parameters for pass and fail also. Okay. So this is how basically you do it. So as I just let us take one more example to understand this. It will be more clear. For example, there is some online learning platform, and it is expected to have 10,000 students log in at 9 a.m. every day. So using JMeter, what you can do is you can simulate this. You can have 8,000 concurrent logins, and you can have 6,000 users who are watching the live video, 2,000 users who are submitting the quizzes, and you can monitor how my system is going to behave. Is there any slowness or is there any crash before we go into live? So you can take like this, you can take any kind of examples to understand load testing. Okay. Now, let us move ahead with another type of performance testing, that is stress testing. So this is also a very, very important type of testing. So let us dive deeply into this. Now, as I told you, stress testing is a type of performance testing and also a non-functional testing in which we determine how my system is going to behave under extreme and beyond normal load condition. So this is related to some load testing. But here we are checking about the high traffic, limited resources, and system failure. So we have to identify the breakpoints over here. So what is the objective over here? Here we actually check whether the system can handle the peak load and or is it able to degrade gracefully. It should not suddenly crash. If it is degrading, also if the performance is getting slower, then also it should be graceful. If there is any kind of memory leak, crashes, data corruptions, are we able to recover from them? Is there any security issues? So all these things are checked into the stress test. So for example, we are checking beyond the limit. So we push the system past the expected load. Then we observe the system, how the system is going to behave during failure, how we can recover after stress, and what are the weak points in a software or hardware. Okay. So see, in load testing, we are testing the expected load, but in stressless testing, we load beyond the expected. Please understand the difference. Okay. And in load testing, we're ensuring that the performance is proper under the normal condition. But in stress, we are identifying the breakpoints. Okay. So what is the goal of load testing? To meet the performance. Okay. And stress testing is to ensure graceful failure or recovery. So that is the difference. Okay. So let us take some real life example to understand stress testing scenario. For example, you have a banking system and you have to simulate a sudden spike in money transfers at midnight whenever your salary is credited. The salary is getting credited in the midnight and then you have to simulate that. Or for example, there are 50,000 users who are trying to purchase a product which is limited edition product at the same time. Okay. Or suppose there is a flight booking portal and there is some flash sale. So there is a rapid booking that is going on. So where all the tickets are booked within seconds. So how it is going to be? Okay. So again, you have the same tools for doing stress testing. That is Apache JMeter. Then we have Locus, which is Python based. We have LoadRunner, which is enterprise tool. We also have K6, which is a modern developer focused performance tool, right? So we have the same tools. So what are the steps involved? Let us understand. So for example, first of all, we identify what are the stress conditions, which is 10 times the expected user load or severe outage or high CPU usage. Then we set up a test environment, which is near to this production setup for accurate result. And then we gradually increase the load until the failure is going to occur. Okay. And then we monitor the system behavior. We track the CPU, the memory, the server logs, the response time, and then we evaluate any kind of recovery that we can do by rebooting the system. And if there is any fixing or bug fix that has to happen, we do it, we document it, and we optimize our resource handling in error. So basically, what do? We find out if there is any crash points, the error rate, what is the data, what if data loss or corruption is happening, and how much time we take to recover from that thing. So let us understand this with a real life usage. So imagine, again, you are having some online stock trading platform during a market crash, where there are thousands of users which are who are placing trades in a panic situation. So what will happen? A lot of people will come because it is a panic situation. So what you will do? You will simulate 5 times the normal load and test how it is going to handle these transactions or log any kind of errors that might happen or prevent any kind of data loss and how it is going to recover if there is any crash. So if there is any crash, are my transactions recovering from it? Am I getting my money back? Right? So all these things are checked under stress test. Okay, guys. Now let us move towards the difference between performance load and stress testing. So as I told you, performance testing is a superset of all these testing, that is load and stress. Whereas load testing is a subset and stress is also a subset. What is the goal of performance testing? To set a benchmark, right, and standard for the application. Whereas in load testing, we identify the upper limit of the system. We set the SLAs of the app and check how I'm going to handle a heavy load. Whereas in stress testing, we find how the system is going to behave under extreme load and how it is going to recover from any kind of failure. So in performance, the load limit is both below and above the threshold of break. In load testing, the limit is threshold of a break, and in stress testing, it is above the threshold of a break, right? So in performance testing, what are the attributes which are tested? It is speed, response time, resource usage, stability, reliability, throughput. Whereas in load testing, we check the peak performance, server throughput, response time under various load level, and we balance. Whereas in stress testing, we check whenever we are in stress, then what is the time, what is the bandwidth, the error control, all these things are tested in the stress test. Okay. So that is all about the difference between the three types of testing. Now, guys, we have covered about what is functional testing and what is non-functional testing. So now we need to discuss about what is the difference between functional and non-functional testing. So when I talk about functional testing, what the system is actually doing is functional testing. So if my login button is performing properly or not, is the registration is happening properly or not, payment is happening properly or not. So all these are part of functional testing. But in non-functional testing, we check how well the system is performing. Okay, so that is non-functional testing. So in functional testing, we ensure that the product meets the customer and business requirement and does not have any kind of bugs. Whereas in non-functional testing, we ensure that the product stand-ups, means the quality, the performance, the throughput, they stand up for the customer expectations. So in functional testing, we verify the accuracy of the software, and in non-functional, we verify the behavior of the software. Okay. So functional testing is always performed before the non-functional testing. So as I have given the example, that is login functionality, it is a functional testing. But when we are checking that if I have to load my home page, is it getting load in less than 2 seconds or not? That is non-functional testing. So there are various types of functional testing like unit, smoke testing, user acceptance, integration, regression. And there are various types of non-functional testing like performance, volume, scalability, load testing, stress testing. Right? So if I talk about functional testing, it can be performed either manually or automated way. So in non-functional testing, it can be performed efficiently if it is automated, right? So we can automate both type of testing, but sometimes there are many functional testing which cannot be automated. Like for example, if I am doing captcha code testing or if I am doing any kind of OTP generation testing. So that is the thing, right? Okay. Now, we are going to start with a very important topic, guys, that is bug life cycle. So let us start with it. Now, what is bug life cycle? What is defect life cycle? Let us understand. So guys, bug life cycle is basically how my bugs is reported. What is the process that happens? So bug life cycle can be a time consuming and a resource intensive process, but it helps us to identify any kind of defects. It improves the communication with the stakeholders and enhance any kind of customer satisfaction. So whenever there is a defect which is reported by the tester, it is actually taking certain state. So when I talk about the states, the very first state is new state. So what happens in the new state? So whenever there is any new defect that is identified by the tester, it falls into the new state. So it is the first state of your bug life cycle, and the tester is going to provide a proper defect document to the development team. So they can refer to the defect document and can fix the bug accordingly. The next state that we have is, guys, assigned state. So let's say what is this assigned state? So here my bug is basically assigned to a developer. So the defects that are in the status new will be first approved, right? And the newly identified defects is then assigned to the development team for working on. So when it is assigned to any developer or certain team, we change the status to assign. The next state that we have is, guys, open state. So now when the developer has started working on this defect, it is being changed to open state. So based upon certain reason, the developer may reject the bug or may fix the bug. So there are various conditions in which a developer can reject a bug. So that could be like rejected or deferred, which we are going to understand in a while. Now, the next stage that we have is fixed. So after doing the necessary changes that is required, the bug is fixed. So the status is then marked as fixed. After fixing a bug, then the tester is going to again retest that bug. So the status is pending retest. So over here, the bug has been fixed. So now the developer team will pass the new code to the testing team. So at that point, the status is pending retest, right, from the tester side. Now the tester is going to retest it, right? At this stage, the tester is going to retest the defect, whether it is working the same or it has been fixed or not. So this status is also called as retest. After that, if he feels that still my bug is not fixed, it has to still, the developer has to still work upon that particular defect. It will go into the reopen state and the life cycle will again continue. Okay. But if the tester feels that now my problem is resolved, it will go into the verified state. So the tester will retest the bug and it is got fixed by the developer team that the tester is not finding any kind of defect in it. So it is verified or fixed. Okay. And lastly, it is closed. That means all the things that has to happen with this bug is done. So it goes into the closed state. So this is how the life cycle actually works. So let us understand the bug life cycle with the help of an example. For example, there is some e-commerce website, right? And you notice that whenever you are searching certain product, the result is coming blank for that particular product, but the product is still there. So you document this issue and you give it a new state, okay? So indicating that the issue has been logged and is awaiting for any kind of review. Then it goes to the assigned state, it goes to the development team, they review it, and upon assessing the issue, they assign the defect to the developer for further investigation. Then the developer will start working on it. So it is an open state. So he finds the root cause, it is from the back end, or it is from the query processing, from where the bug is coming. So now it is open state. Now, if the developer resolves the issue by correcting it from the back end, it is marked as fixed, right? So it will say that the necessary change has been done. So then it will go into the pending retest because now it will ask the tester to test this functionality again, whether it is working fine or not. So the tester is going to test it. He is going to retest the received updated code. And he will check whether the search functionality is working properly or not, whether it is able to fetch the data from the database. And once you check that, yes, now it is working fine, the issue is no longer present, he will mark that as verified. And then lastly, it is going to closed. Now, as I told you that there could be a situation in which the developer can say that we cannot fix this bug. So what are those states? The very first is rejected. So if the developer teams reject a bug, they feel that the defect is not considered as a genuine one. So this is not a genuine defect. It could be a duplicate defect. It is not a defect or non-reproducible. So, but if a tester feels like, yes, it is a genuine defect, he can just document it, right? But from the developer end, it is rejected. Next is deferred. So all the defects have a bad impact on the developed software, we all know. But their level also is different. Some defects has a very low impact and some defects has a high. So if the defect is not of prime priority and we say that in further update or release, we are actually making this resolved, then we say this as defer. Means that you can terminate from the current defect life cycle, but yes, later on we will be working on it. Then is duplicate. Sometimes it may happen that you have already stated the reason for a defect, but still it is coming to you again and again. So you will say that this is a duplicate defect. Then we have, it is not a defect. So if the defect has no impact or it's not affecting the functioning of the software, so you can say it is not a defect. It might be because of the environment that is working. Then it is non-reproducible. That means it is due to the platform mismatch. or data mismatch or the way you are using it. So we can't reproduce it, right? The next is it cannot be fixed. That means we do not have that much of technology. We do not have that much of skills that we can fix this kind of bug. So it can't be fixed. And the last one is need more information. So the document that you have given to the developer to solve a bug, the problem that you have given, is not enough to understand what problem you're facing. So you need more information. So that is all in which you can actually reject a bug. Now, guys, every bug, as I have just told you, has some impact. So that impact is nothing but the severity of the product. And how soon we have to solve is nothing but the priority of it. So severity basically means the impact of the defect on the functionality or performance. And priority basically refers to that how soon we need to fix that bug, how it is going to give an impact on the business. And based on that, we have various level of severity and priority, which so the levels of severity are critical, high, medium, low, and the levels of priority are high, medium, and low. So let us understand this with the help of an example that what basically severity and priority means. So when I talk about severity of a bug, then this is basically assigned by a tester. So we are telling how badly that particular thing is affecting my system. So if I say critical, that means the system is getting crashed or I'm having some data loss and there is no workaround for that. That app is not working because of that. So that is a critical. High means that the major functionality is broken, right? And medium means that the functionality works incorrectly. The way it has to behave, it is not behaving like that. But we have a workaround for it. And low means it is a very minor issue. It is not going to impact, but yes, if you are able to fix this, it is okay. Similarly, what is the meaning of priority? So priority basically refers the order in which you have to fix it. So this is assigned by the project manager, not by the tester. So how soon you should fix this bug? High means you have to fix it immediately because it is going to block my release. Medium, basically it should be fixed in my life cycle. And low means you can fix it later in the future releases. Okay. So severity is going to be my technical impact and priority is going to be my business urgency. Right. And that is why severity is given by the tester and priority is given by the project team. So in severity, we focus on the quality and priority is all about delivery of that particular software. Right? So severity is what? Based on how bad the issue is, and priority means based on how urgently it needs to be fixed. So there could be various combination of a bug with the severity and priority classification. So for example, let us talk about a bug with high priority and high severity. So for example, if my login button is not working, so I can't use the app if my login button is not working. So the priority is also high and the severity is also really high. Right? And for example, let us talk about high severity but low priority. Means we do not have to fix it right now itself. We can fix it in the later version. For example, there is a crash in any unused or rare feature. Like for example, there is some feature that is there like contact us button or something. So it is impacted because we are not able to contact the particular website owner. But the priority is low because maybe it is because of some discrepancy or something that is happening inside. So we can just fix it later. Okay, so priority is high. Severity is high because over here contact us is not working, but it is low. So there is a crash. Okay, so we are not fixing it right now, right? Then low severity and high price. So it is not going to have an impact on my system, right? So if it is a low severity, like for example, there is a spelling mistake or the color of the font is not that good. So it looks very unprofessional or the logo is missing. So that is severity is very low. It is not going to impact my system. There is nothing like which is not working. Okay. But the priority is high because it is going to reduce my business standards, right? And then let us talk about the combination of low severity and low priority. For example, there is some misalignment. The page is shifted little towards the right side. So that is not going to create a lot of issue, right? Or it is not going to impact my system. So that is all about low severity and low priority. Okay, so severity is all about how, let us talk about a real type example of severity and priority. You will understand it more. So severity, suppose we have a cut on our hand. Okay, so severity is how deep the cut is. And priority is how soon you need to get it treated. Right? For example, there is a deep cut, a severe cut on your leg. Okay, and it needs urgent care. So that is a high priority and high severity. For example, there is a deep cut on a non-visible part of body, right? But it is severe, but not very urgent, right? It is not visible, so you are not giving that priority to it, right? Or for example, there is a small pimple on your face. So it is not severe, but it is high priority because you're going in a meeting and it is not going to make you look good. So that is how the real life things you can think of, right? So high priority, high severity basically means the key feature are not working properly. And high priority and low severity means that the basic feature failed, but it has a huge impact on my customer business. And if I talk about low priority and high severity, means key features are failed, but there is no impact on customer business, right? And low severity and low priority means some normal font family mismatch, some cosmetic issue. Okay, so this is all about the bug life cycle and severity and priority of a bug. Now, guys, let us move ahead with the difference between regression testing and retesting. So this is a very, very important thing that needs to be covered. So regression test cases are carried out to basically search through all the previous updates and features of the software to find any unforeseen defects and bugs. So basically, regression testing is done whenever there is any update, whenever there is any new release, so that you check all my previous functionality are still working the way they used to. Whereas retesting is just a part of your bug life cycle, wherein you retest only those defects in which we have found certain error. So what is the objective of regression testing? To check that the new code changes has no negative impact on my existing functionality. Whereas retesting is to just check that whatever defects we have identified are fixed. So regression testing isn't a targeted testing for defects, whereas retesting is just for the defects, right? So automated regression testing is a logical question because of frequent changes and update. So since retesting checks for a specified defect, it cannot be automated. So based on the project and the availability of resources, regression testing can be carried out parallel along with the retesting. Right? So retesting is done based on the priority and severity of the bugs. Right? So regression testing is used for past test cases, whereas retesting is used for failed test cases. So regression testing is more time consuming, guys, right? Because we have to explore the whole application, whereas retesting is less time consuming because we are just focusing on a certain defect. Now, let us move ahead with a test case for a real life entity. So now we are going to discuss about the test case of a AC remote. So we are just going to discuss about how do we need to write the test case of any real life entity. So I'm going to discuss about an AC remote. You can think about any real life entity like a pencil, like an ATM or a lift or a coffee vending machine. For example, the knob of the door. So you can think about all these examples. So let us discuss how do we write these test cases. So for example, I want to talk about the positive test cases of a AC remote. So what it will do? So the power button. So we verify that when we press on the power button, it will on, and when we press off, it is getting off. Whether the temperature is getting adjusted as mentioned with the increase and decrease option. Whether we are able to select the mode, cool mode, heat mode, fan mode, whether we can control the speed of the fan, that is high, medium, low. So you all know these real life entity. You are all using it. So you just have to think and give a little bit idea about it. Okay. You also have timer setting. So whether you are able to set it or not. You also have swing feature. You can just check whether the swing is working perfectly or not. So these are all positive test cases. Let us discuss about the negative test cases. So negative means when there is a low battery condition, how the remote is going to be used. Till when it is going to be hit if it is a low battery condition. If you give invalid button combination, how it is going to be used. right? If it is out of range, the AC is in this room and you are trying to open the AC from different room, how it is going to behave? Or if there is any button malfunction, that means the increase option is working like a decrease and decrease is working like an increase, right? So these are all negative test cases. So you always have to write both the test cases. What is happening if there is extreme temperature? So if my remote is kept as an extreme hot or cold temperature, how the performance is going to be affected, right? If there is something that is coming in between the AC and the remote, how is my remote still working on? Okay. Then we have some functional test cases. For example, we ensure, see, we have a simple remote, single remote for each AC, right? But you have also seen that the same remote sometimes can be used with a different AC of the same brand. So we have to always ensure that remote can pair correctly with different AC, right? So that is the functional testings. Then we also can check about the swing function, changing the airflow direction. So that is a positive test case also and functional test case also. Then we also have sometimes energy saving mode, right? Or the LED display, which shows you the correct information. So that display is showing you the correct information or not. Maybe the display that is coming on the AC is different from what is coming in the remote, right? So that is all functional test cases. Similarly, we could have user interface test cases. Here we talk about the button layouts. So whether we are able to click each button separately or they are too close to each other. The clarity on the buttons is properly mentioned or not, or we are not able to understand. The brightness is sufficient or not, right? How much sensitive that button is. What amount of pressure we have to apply to press that button, right? How we are able to navigate from one function to another, right? What is the durability of that remote? So that is all about user interface. Next, we could also have usability test cases. So there could be a situation where you cannot write so many test cases for a real life event. So it is not like that you have to write so many test cases for every real life event. You just have to think what the real life event is. Then we have usability test cases. For example, the ease to use it. The manual is there or not. The error messages are coming properly or not. Right? The satisfaction of the user. We gather the user feedback. Whether we can replace the battery or not. Whether we have child lock feature or not. So all these things comes under usability testing. So that's all about today, guys. So in today's session, we have discussed mainly on non-functional testing. So non-functional testing is a testing that can be automated using the tools like JMeter. So there are a lot of testing which comes under non-functional testing, wherein we check the behavior of the application like performance testing, load testing, stress testing, security testing, scalability testing, and more. Then we understood about what is bug lifecycle, what are the different status of a bug, and when do we say that the bug is not accepted. We also understand what is the severity and the priority of a bug. And we discussed about the difference between regression testing and retesting. And lastly, we created some test cases of a real life entity that is an AC ring. And similarly, you can try to write some test cases for a pencil, for a pen, for an ATM machine, and so on. So that's all for today, guys. Thank you so much.